In this video, we're going to talk about the right-hand rule. So I have two rules to show you the direction of the magnetic force and the direction of the magnetic field. So the first right-hand rule, you stick your hand out and you have your fingers just like in the picture, so all your fingers are at right angles to each other. And A, your pointer finger, is going to represent the current. So you point your pointer finger in the direction of the current. B is your middle finger, and that's going to be the magnetic field. So you point your middle finger in the direction of the magnetic field. And what you're left with is your thumb is going to be pointed in a certain direction. And the direction your thumb is pointed is going to be the direction of the magnetic force, which is shown in purple up there. And so all you have to do is keep your hand like this and turn it and manipulate it. Don't turn your fingers. Manipulate your hand until it looks like the situation that's given, and then the thumb will show you the direction of the magnetic force. And then just two writing conventions is that a circle with a dot means out of the board, and a circle with an X means into the board. And that's, you can think about that as an arrow. And if the arrow is going away from you or into the board, you would see the feathers on the arrow. And if it's coming towards you or out of the board, you would see the tip of the arrow or just the dot. So whenever you see that, that's just what I mean. So I have two examples down here. So if you have a current that's going up, so point your pointer finger up, and the magnetic field's coming at you, right, circle with a dot, so your middle finger is now pointed at you. Your thumb should be pointed to your right, and that's the direction of the magnetic force. The second example, if the current's pointed down, the magnetic field is going to your right, then your thumb should be pointed towards you. So the magnetic force is coming towards you. And this is just showing you that if you get the magnetic field and the current, you can find the direction of the force. And that it's weird. It's not straightforward. It's always, the magnetic force is always perpendicular to both the current and the magnetic field, which is kind of strange to us. And this is how you find it. And make sure you use your right hand. Okay. The second right-hand rule, what I call the second right-hand rule, is to find the direction of the magnetic field. So remember that currents, or moving charges, produce magnetic fields. And then if you're a moving charge in a magnetic field, you feel the magnetic force, right? That's the first right-hand rule. Well, what if we want to find the direction of the magnetic field produced by a current? Well, use the second right-hand rule. And in this one, you put your thumb in the direction of the current, and the curl of your fingers shows you the direction of the magnetic field. So in the picture here, if your thumb is pointed up, you see that your fingers are curling kind of in towards you, and we could call that, like if that were a clock, that would be counterclockwise, right? And so if I put my thumb down, if the current were going the opposite direction, down, you would see that my fingers would curl clockwise. So the two horrible pictures that I've drawn here, so if the current is going to the right, so point your thumb to the right, the curl of your fingers is coming kind of, I would say, at you, okay? So if this is a wire, then above the wire, the magnetic field, your fingers are coming at you, right? But they make a concentric circle. So when they're going below the wire, they're going to go into the board. So I've drawn out of the board here and into the board here. And you've seen my bad picture of those circles. And if the current's going in the opposite direction, oh man, that one's really bad, I'm sorry. And your thumb's pointing to the left. And now, kind of above the wire, you can see the magnetic field. The curl of your fingers is going to go away from you and then kind of curl back in towards you at the bottom. Remember, that just stems from magnetic fields always being concentric circles. So then the direction ends up being something like clockwise or counterclockwise. So if I have two wires and the currents are both going up and they're parallel, this first wire will create a magnetic field around it going, I guess, counterclockwise is what we'll call it. And you'll see that at where it hits this other wire, it's going into the board. And for this wire, where its magnetic field hits this wire, it's coming out of the board. Well, now we have the direction of the current and the magnetic field at that point, right? So I can make a generalization and say everywhere along this wire, the magnetic field from this is hitting it out, and the magnetic field from this one is hitting this one in. I now have direction of current and magnetic field, so I can use the first right-hand rule and find the force, and you'll see that the force is going in for both. So two parallel wires will attract from the magnetic force.